Welcome to the Agriforwards CDT Science Seminar Series. Today, Eliot Dixon from the Agri-EPI Centre will discuss with us his experience about data and automation and robotics and challenges that we are currently facing in agricultural robotics. Who is Eliot? Here is Eliot Dixon, expert in robotics, sensor data engineering, currently working in the Agri-EPI Centre with experience that goes beyond agriculture. For example, he worked in automation, engineering, precision and innovation, and so on and so forth. He's been a software engineer at Automotive, so he has a variety of experience, and now, as a last adventure, he's working in particular in the agri field. Creating a database for farming and testbed and so on and so forth. So there is a lot to learn. Without further delay, please, Eliot, eager to learn. Thank you very much.
Thank you very much, Fulvio. I'll share my screen on the slides with you again. Right, you should be able to see that okay.
Yeah.
Let's go back one. So yes, I'm Eliot Dixon. I work at the Agri-EPI Centre, so Engineering Precision Innovation Centre. I'm fairly new to the company, so my new job title is Autonomy and Data Lead. I want to talk a little bit about my background. So you can get
Eliot, I'm sorry, we see the presenter view together with the slides on the background.
That's very strange.
So yeah, if you move that window, okay, now we see only the slides. Yeah.
Sorry, let me try to do my sharing this.
Yeah, now it seems to work.
Okay.
Please go ahead. Thank you.
Zoom can be a bit awkward. Okay, so my background, Fulvio went through it quite briefly, and I think it's useful to talk about it so you can see where I'm coming from with this, because I'm very new to agricultural robotics. My personal background is agriculture. Far back, come from an agricultural family, but I sort of grew up on a farm. That was a bit too techy to stay there at the time, so I moved in. Into taking some robotics there at the top, University of Birmingham. Then went to the MOD, working for the STL, so the Science and Technology Group. There I was working mostly on radar and UAVs in hostile environments. And then worked there for a few years and moved to Tata Motors, UK division, working on their autonomy team. I was lead software engineer on the autonomous vehicle. You see in the center of that image there, part of a large collaboration with us, Jaguar Land Rover, and what is now called, I can't remember what they're called anymore, but they're producing some autonomous pods. And now I've moved, as that space gets very, let's say, serious and moving towards production, I've moved into the agricultural domain again. It fuses my two interests quite nicely. Let's talk about Agri-EPI Centre, where I work. So I don't know how many people know about Agri-EPI Centre. I think it's not massively well known really still, as it should be. We are initially a government-funded group, set up about 5 years ago now, with funding and support from Innovate UK, from which we still receive significant funding. We're cross-sector, so we're working across all agricultural domains, but really focusing on precision agriculture and bringing new technologies into all the agricultural domains. There are 4 different Agritech Centers. As I said, we're precision agriculture. The other ones are agrimetrics, so they're data science focused on sort of a national scale. We have a bit of a data science side, but that's working on the field scale, small scale data science. CHAP is looking at soil health and crop health, and SEAL is the livestock focused centre. We all work together, we're all very closely aligned, we're working for the same overall goals of enhancing the UK agri-tech domain. As for Agri-EPI Centre, our 4 key focus areas of development are in agricultural robotics and agricultural engineering. Then we have precision crop techs, that's developing new precision farming methods and investigating new tools for precision farming through different projects and trying them out in our facilities. We also have an area where we're looking at precision livestock and precision agriculture. So these are things like automated milking machines and various changes in methods that requires. And we also look closely at data at a farm level and trying to use that to enhance precision agriculture. So we're quite wide in scope, I'd say.
Eliot?
How do we do this? What's that? Sorry?
Sorry, you froze for 20 seconds. If you can restart from the beginning of the slides, please.
Cool, sorry. Right, so yes, we act as an enabler for agritech across the UK. We're mostly UK focused, but we do try to spread the technology developed in the UK worldwide. So we're working with international partners. We have projects, active projects in Kenya, China, and Paraguay right now. This is disseminating ideas within the UK and internationally and trying to influence policy in the UK as well and spread the effect of UK agriculture worldwide. We're also helping to form research projects across all of our core areas. This is us helping.
Eliot, unfortunately, you're frozen again. Hello, Eliot.
Helping to
Eliot?
It looks like he's, oh no.
I think the sharing of your screen is not in place anymore. So perhaps because of bandwidth problems, you are not sharing your screen anymore and you were frozen for a bit of time. So if there is anything you can do for your connection, that would help.
Yeah, I can't. We have a plan B. So Veronica, could you share, please?
Yes, just 1 second. I'm actually trying to share my screen now, starting from the slide you have. Just 1 second.
Sorry about this. Having a bit of a bad day. It's normally a very fast connection. I can't see from this end what's causing the speed issues.
Veronica, I'm happy to do that as well. So if you like to send me the slides and I can visualize them, it's fully up to you, whatever you prefer.
I'm trying to, okay, just 1 second. I will try to share my slides. Doesn't give me the option to share the slides. That is really interesting. Okay, sorry, technical delay for a second. I'm going to resend the slides to full view because I have no option to share right now.
Are there movies in your slides, Eliot, or are all fixed?
No, it's all static.
So just emailed it to you, Fulvia.
To mute of me, Veronica, I didn't receive anything so far.
I'm just uploading to a different location, Fulvia.
Okay.
Yeah, and then you would be able to download that from there.
Okay, I received them.
Okay.
You should all see the slides now.
Yep, I can see them.
Lovely.
This is where you were, right?
No, that's it. Okay. I'll just finish off on this one. Okay, so what is that? So we act as an enabler for UK Agritech. We're here to bring everyone together from research and development and help them engage with the agricultural community. There are various different ways of doing this. I think where it got to, we do is knowledge sharing. We also do a fair bit of work which is directly assisting in technology development. That's through using our facilities, our tools, our agricultural trials capabilities. To help us with this, can we go to the next slide, please? To help us with this, we have a whole set of facilities spread right across the UK. Our main bases, let's start at the top. Our main base is University of Edinburgh at the Easterbush campus. This is quite a bioscience-focused campus in general. But here we have a set of labs which we can share. We have some training spaces, we have offices, spectroscopy centre, and also a new aquaculture facility that's been opened just outside of that base, you know, the western coast. We've also got a base a bit further down at Harper Adams University, so obviously a great agriculture university. Here we've got incubation spaces for startup companies as a lab space. We also have incubation offices and various large workshop spaces. And these are, well, I think, fully occupied right now. We come in that occupation relatively quickly as people move through them and start being in a position to set up their own facilities. And then our final large base is Cranfield University, and that will be our southern hub. That's where I'm based, just outside of Milton Keynes. Obviously, Cranfield is a big technology research university. And here we have our large glass house with a phenotyping platform. So that's LiDAR, camera, I think thermal imaging as well, which is used to measure and understand the growth of plants. And this has been used quite a bit in the past, actually, for robotic projects where they're trying to ground truth some of their sensors. We also have workshop spaces there in our brand new office space, which includes office space. And there's where we keep most of our technical equipment as well. So we've got a whole range of drones and sensors which we can deploy onto projects to assist where needed. We're also in the process of buying a few extra pieces of equipment. We've got a robotics platform we're looking to purchase, and also some new, more modern drones, which may help some people's robotics development, or more specifically, robotics component development and perception development. Sorry. So these assets will break down into rough areas, and got some more here as well. Actually, let me discuss two more. So there's the Southwest Dairy is another big base. No one's really based there. There's one person based there. But the Southwest Dairy Development Centre is a very large, not very large, but very sophisticated dairy with using latest robotics, latest methods for dairy farming to try and really show the best of what is possible with modern dairy technologies. It's very well worth a visit if you can ever wrangle a visit there. It's quite fascinating. Then we also have the calf research facility at Harper Adams and at Piggery as well. Again, showing the very best what can be done in those areas. And finally, one of our bigger resources in terms of national scale is our satellite farm network. This is a network of 25 very innovative farmers we work very closely with. They're there to help us directly deploy new technologies onto farmers, and we're always very keen to see what is available. Also there to help us understand the issues they're facing and the problems that are in the marketplace, and they're a very valuable resource for us. They're also there to help us gather some ground truthing data and understand what's happening on farm, and we're slowly building up a data platform to centralize all this data and make it quite an enviable resource for machine learning and for generally being a test bed. Fulvio, could we have the next slide, please? Thank you. So assets, yeah, split across various different areas. I'm not sure much I can add to this one. Another area, can we go to the next slide, please? Another area we try to help is we've built up a very large member organisation. So this is organisation members. These are companies who are companies and institutions which are very keen on the agtech sector, and they want to invest in the sector, or they're developing new technologies for the sector, or just have a general interest. So you'll have quite a few large names are recognised here, and some which are a lot more sector specific. We work with all of these and try to form collaborations between them and a dialogue between them on a regular basis to understand their separate needs and understand the full, let's say, ecosystem from fork to farm to field. What's this word? Field to fork. That's it. The full chain there, and understand where everything fits in and where we really need to focus our work. Got some examples, or an example so far, of some projects we've been doing. So if you go to the next slide, please. So one big project we've been working on, this one's finished now, we've moved on to another 5G project. It was 5G rural first. This was a big collaboration. The main demonstrations here, which have a robotics focus, were the connected cows demonstrations. This was fitting cows with connected collars with a 5G link ultimately to help detect early health issues before they really become a problem. We're also looking at biomass measurement using drones for hay, and we're also part of the hands-free hectare now moved into hands-free acre. I believe we're project managing hands-free acre to some degree. Obviously a very large robotics project, and there are others in the pipeline. I literally just heard, whilst we're having that technical issue, that we've won some innovation pathways funding for an orchard robot to develop that, which is really quite exciting. Looking forward to that one. Okay, so that's Agri-EPI Centre, and a lot of what we do is trying to discover some of the issues and see where we can really push agriculture. So could we go to the next slide, please? And these are some of the problems we're seeing right now, which are really core to what farmers are looking at. The big one we hear about is a labour shortage, somewhat caused by Brexit, sometimes COVID, and just a general ageing agricultural population. Tens of thousands of people short overall, depending on the sector. Another area where farmers are facing issues is in tighter restrictions on quality. High quality restrictions is also means to detect that. Also, there's massive legislation changes coming. The end of the Common Agricultural Policy with the EU. It's causing a reduction in direct payments. This is changing the focus of funding and, to a large extent, therefore farming in general, onto soil health, onto biodiversity, onto ensuring natural habitats are looked after. That's all part of the environmental management scheme. And there's also potentially some bans on chemicals coming up in the future, which could have a massive impact. So farmers are really having to think about these. Next up is climate change, so variable weather patterns. Fun statistic here is that compared to 1960, days are 17% wetter than they are back then, and periods of extended rainfall are now 7 times more common. So from something that farmers have seen for some time, that there really is mounting evidence that this is a problem people are facing on a day-to-day basis and yearly, and really changing the way farmers have to think about going about their operations. We also have a net zero aim by 2040. So as a company, we're very much focusing on carbon capture and generating potential revenue stream for farms there. Animal welfare. People are starting to see animal welfare more importantly. So farming practices are slowly having to change. And this is perhaps contributing to a fairly stagnant UK meat market, and also perhaps contributing to global competition as we leave the EU and bring in new agreements for other countries. There's definitely a worry there as well. So all of this means what we really need to do is focus on increasing efficiency of farming in the UK whilst reducing the costs inherent in that. And that's where precision farming comes in, and to a lesser extent, regenerative agriculture. And key to that are robotic solutions. Many of these are in development, as we all know. So let's talk about those briefly. So can we go to the next slide, please? So robotics is meeting this challenge through various different solutions. So we're all familiar with, well, probably all of these, to be honest, but they all have different things in common. It's worth talking about them. So partial automation, here we're looking at systems which are using some of the technologies involved in robotics. So perhaps vision, that on the left is what we call RoboCrop from Garford. It's using vision to detect weeds and weed around them, using some robotics technologies. Then we're moving on to autonomous robotics in a controlled environment. These robotics tend to be a bit more similar to what you would have seen in the university a few years ago. That particular robot's a robot from Dogtooth Technologies. Here we're thinking about picking and packing in controlled glass houses, greenhouses, and sort of environments. Then we move on to autonomous tractors. This general concept is to take a normal tractor operation and automate it. Largely seen vineyards is quite popular, and some field operations. Yet to see this take off to any large degree. Then lightweight infield robotics, I'd say is the more innovative branch of robotics here, completely transforming the way we go around doing agriculture in the UK. Very lightweight to avoid compaction, looking at agriculture on a per plant level rather than the field scale. active area of research, not quite ready for mass use yet, but getting there. And finally, there's a whole number of different companies. I think we have about 5 that we work with in one way or another that are focusing on building autonomous scouting and handling sort of smaller robots, not necessarily designed for the field environment, but designed to be rugged and trying to find different use cases where they can fit in around the farm. Not specialized, but they're looking into novel technology, novel sensors and actuators to make these make sense in an agricultural environment. The point here is all of these different solutions share very similar challenges. Can we go to the next slide? And also the way the companies that develop face very similar challenges that we've seen and I've had companies talking to us about. So one is that the use cases are still fairly open. Currently, the uptake of robotics, agricultural robotics, is quite poor. And perhaps this is very much due to the lack of a really key use case which makes financial sense right now with the current technologies. There's also some poor revenue streams. New technologies require massive investment, but the options that are available are highly competitive to get that money. Many people going in for it. I think one of the recent funding calls was something like 500 applications for about 20 funding opportunities. So highly, highly oversubscribed. Development seems to be somewhat fractured. So everyone's working on similar technologies, but to some degree, everyone's quite separate in how they're doing that. And it feels like that needs to be brought together. The technologies that are being developed because of the revenue streams, unfortunately, largely, and the need to focus on a single use case to make it make sense. I think quite a few of the technologies are going to find it quite hard to scale up from there. And finally, insufficient skills, but thankfully, the CDT is working very hard towards fixing that problem already. But all of this really means that there is a need right now to start increasing our technical collaboration and knowledge exchange. Talks like this go a long way towards doing that, but it needs to increase further. It's not just within the industry, so we're getting quite good at talking amongst ourselves, but maybe we need to improve how we're talking with other industries. And as I'm from an automotive background, I'd suggest that automotive is one of those key industries because many of the technologies faced by us right now have also been faced by the automotive industry in the past. So let's have a quick look at the automotive industry and some of the 2 or 3 key technologies which can move over directly. Could we go to the next slide, please? Now, I'm suggesting the automotive industry as a way to bring in new technologies because they've been in this area for a long time. They have very good experience. So ADAS, Advanced Driver Assistance Systems, they've been in development for nearly 30 years now, more than 30 years in fact, using very advanced sensors, many of which are directly applicable to the industry right now. This area is also very supply dominated. So technology development, instead of being spread around OEMs and the car manufacturers doing the autonomy development themselves, I know that the big players we talk about like Wave that are developing a system from the ground up, but largely speaking, it's supply-led. So it's Continental, it's Bosch working on these technologies. This means that they're working very hard towards low prices, to be honest, high volumes. But this isn't really about the manufacturers of the cars holding onto IP. This is about the suppliers generating the IP, and it's allowing for a fair deal of new ideas, but also allowing the prices to come down. So there's a lot of cheap solutions in this market. Also, we're seeing that because precision farming is a fairly consistent growth area, but because automotive is stagnant, quite a few automotive suppliers are starting to enter the industry. We're getting approached by quite a lot who want to start engaging with the sector because it's very attractive. This is a good thing for us because we can start drawing all these technologies much more easily.
Eliot, we lost you. Hello.
Well, tell me when you can see me again. Oh, I see you've moved. So
okay, now we can hear you. I think 20-second break we had. So you were saying that automotive is moving into the field and is good for us because of investment, and then there is where it dropped. Hello? Eliot? Okay, so I guess Eliot is reconnecting. Okay, now you're muted.
Sorry, it's not going well, is it, in terms of connectivity?
It's fine, it's fine. You were saying that is a good thing that automotive is moving in, because this means new investment in a certain sense, but then from there we lost you.
Okay, we're not getting very far, are we? Okay, so there's similar requirements. So we have rugged systems. Automotive is also looking for rugged systems, also with high reliability and capability, and also looking for systems which are on the same basic underpinning technologies, at least for larger vehicles, of a CAN network. We call it isobus, basically the same thing underneath. I'll have the next slide, please. And the next slide. So I'll really quickly go, because I'll go through some slides here, because I know we've lost a fair bit of time. But we'll talk about some very specific technologies which could come in from automotive, or very specific sensors, in fact, that could come in from automotive and form part of an autonomous chain. So first off, in the autonomous control loop, we've got sensing. We need to gather some data. In automotive, this is largely driven by tier 2 suppliers. So that's not Bosch, that's the layer below. That's companies like Texas Instruments and Renaissance and many others. They're developing specific chips, specific radars, specific vision models, which are integrated by the larger companies. These tend to be quite accessible outside of automotive as well. You can go and buy many of these technologies as a one-off relatively cheaply. Radar, again, massive main technology, I'd say, for automotive sensing, at least for ADAS and autonomy. It's been around for a very long time, clearly. The latest development is we're moving towards increasingly cheap sensors as the capabilities get better and we get smaller technologies available. But these have significantly higher resolutions than the original radar sensors, even from a couple of years ago, when we start talking about cascaded or ray-based radars, which is, increasing the capability of very fine object detection and to some degree recognition as well. It's now capable of radar. These are usually very good systems with excellent noise suppression, but they struggle with lower speed, smaller targets, and identification in general still, even with the high resolutions. So we need to look at other sensors as well. The key one to be combined with radar is a vision sensor. Not been used quite so long, only about 20 years. The market here is completely dominated by a company called Mobileye out of Israel. You might be aware of them. This is a camera that tends to be standalone with perception integrated in it. So it's something you could buy and integrate with your system to some degree. Originally, we're using traditional image processing techniques like edge detection, but are now wholly moved into looking at convolutional neural networks mostly for higher speed and higher accuracy. Very sophisticated systems now. Admittedly quite focused on the road environment, but their models, I'm sure in previous conversations, are quite easily transferable to other environments as well. Excellent for detecting and confirming objects, not so good at placing them in 3D space. That needs to be improved. So they do tend to get used in fusion with a radar to enable that. And finally, the big sensor, LiDAR, still very expensive, but very high capability. This tends to be used when you're looking for something with very high-end automation, so level 4, level 5, because it gives you many of the capabilities for the two sensors. There's a fair bit of overlapping capability, but also with the downside of paying high expense. So it gives you that duplication, which is very useful if you want high reliability. All of these are also available, as I mentioned, as a retrofit kit. So these are the kind of things you could buy and integrate with your agricultural robotics relatively easily. Another area which I haven't really mentioned here is Vtx Technologies. So connected vehicles has now reached a point in the automotive world where it's in common use. Might be some use in agriculture for swarming robots. And I'd imagine people are looking in that area anyway, because it's good technology. Here we're looking at DSRC and LTE as the underpinning technologies for now, potentially moving into 5G derived ones in the future. Another place where you can go and buy, come in the next slide please. Sorry. Another place we can go and buy solutions off the shelf from automotive companies is in perception. So I've ignored sensor specific perception. This is perhaps another layer up from there. Sensor fusion, mandatory in autonomous vehicles, but could be used in agricultural vehicles as well, especially larger ones where you do need 360 degrees of perception and of vision understanding. Allows optimum performance from your sensor array, available as very easy to integrate off-the-shelf solutions from a few different suppliers. One I've worked with in the past is Base Labs, but there are many available. We also have a concept of semantic mapping. I think from a talk I've seen before with some of you guys, this has already been looked at quite a lot. Perhaps using the lane look model pulled directly from this industry. So perhaps I can't say much here. This is really dividing the environment into what can be achieved and where the robot can go. Big suppliers in the automotive industry. So whilst the lane look concept has been open source for quite some time, there are various manufacturers, so TomTom and Here are big suppliers who can produce these high definition maps relatively easily in automotive context, but the same concept can be moved over to agriculture. Okay, come to the next slide, please. Let's go to the next slide, please. Skip that one. The final area, and this is quite a broad one I want to talk about, is the underlying platforms and methodologies that allow development of these technologies. So everyone's very familiar with ROS. I think it's fairly ubiquitous in the industry right now. Same with ROS 2, increasing use. These are not used really much in the automotive industry. Everyone's very focused on AutoSAR as a middleware platform. And this was originally just AutoSAR. That's now called AutoSAR Classic platform. There's also the AutoSAR Adaptive platform. These are for mission critical use cases, so autonomous vehicles. AutoSAR Adaptive is building upon the original embedded platform to be much more sort of Linux compliant, POSIX compliant, allowing to run more modern and complex systems on that middleware with fairly modern methodologies of doing it, and it's getting very widely adopted. We also have increasingly another company appearing, producing what's called Apex OS. This is a branch of ROS 2, so you're probably fairly familiar with it. But again, this has been modified for mission critical type areas. Whilst the agricultural robotics is perhaps not mission critical, it would benefit greatly from the robustness that we brought in with a system such as this. This is also very closely aligned with Autoware Foundation, which is building as an open source platform many of the components you need for a high-end autonomous system. From a processing point of view, everyone is now moving on to single board computers, where as much as possible on the car is software defined and being run in a single place. The old model is everyone had individual sort of highly embedded processing. We're now moving away from that. Everything's being centralized, now more software defined. Perhaps the most well-known is NVIDIA Drive AGX platform. Some of you may be working on similar platforms or perhaps even the same platform. Very powerful, also very expensive, but the traditional manufacturers in the area like Texas Instruments and Renesas also are working on very similar sorts of platforms which have some of the same vision capabilities, perhaps slightly lower down in processing capability, but still very capable. All still POSIX compliant, so you can use a lot of the same code. Still quite high compute power and low energy consumption, but much cheaper, and can also be purchased in small volume development kits, which is quite important. Or people can design specific use case ones for you as well. And I think finally, I want to talk about simulation coming from the automotive space, which is getting increasingly sophisticated, able to replicate surface conditions very finely, starting to move into off-road simulation as well. This image is from RF Pro, which is perhaps the highest end of these simulation systems, and is being integrated into a very large NVIDIA-based simulation system. This is vital in the autonomous world. No one in automotive would dare to design an autonomous vehicle without
Eliot, we lost you. Okay, I think we have you back. Please go ahead.
Okay, I think I'll finish then. So, key points taken from this. Agri-EPI Centre is here. We're here to help you accelerate your research from research into production, so as I was describing it earlier. We're also that everyone's facing very similar challenges and will benefit from more collaborations. We're here to try and facilitate that. And we're also here to try and facilitate you working with other industries and helping to bring their technologies from their world into agriculture. Yeah, that's all. Thank you.
Thank you very much. Also to handle communication that was not very streamlined, but I think essentially everything went through. Okay, so now, please, if there are any questions, feel free to raise your hand or to ask directly. Maybe in the meantime, I can start to break the ice. So well, you have an extended network and you do a lot of things, essentially. How can we get in contact as academic, as students, if we have an idea project, or if we just want to collaborate and get advantage from all the plurality of things that you do? As a CDT, how can we get in contact with Agri-EPI Centre practically?
It's relatively easy. I think primarily I'll be your contact, and I can put you through to the correct people. The way we tend to work is we're very focused on helping you engage with collaborations and building large collaborations. So I think the process tends to be you can come to us with what you want to achieve, and we'll try and help you find the correct partners across our network and build that into a collaboration. Sometimes we can help you find direct funding in some cases. Sometimes we can help you find other technology partners interested in building a single core project, because they might have other pieces of the puzzle we're trying to solve. So
do you do some open days, or there is a button, click here to help for help on your website? How do we do that in practice?
Yeah. So yeah, there are various methods. You can contact me directly. You can go to the website and there is a contact form in there, which will come through to one of us. And we'll be honest, probably quite a few times it says robotics in it, end up coming to me anyway. We also have very frequent webinars that come up. You can find them through our website, YouTube, Facebook, LinkedIn, I think, and they're on a very frequent basis. I think we have one monthly. There's one coming up on robotics subjects in about a month anyway, which should be quite interesting. So if you look out for those, that's a way to engage and start meeting some of the community. And then from a corporate basis or company basis, if you have a team, you can engage with us through our membership network, and that will give you direct, regular communication from a member of the team and opportunities to present to the rest of the network.
Okay, thank you.
Amongst other things.
Yeah. Mark, please, go ahead.
Thank you, Fulvio, and thank you, Eliot. That was really interesting. Hope you can hear me relatively well. I'm curious to what extent there has been an uptake of the automotive technology into the agriculture, because you said this is a great opportunity, and it's kind of an obvious one. And I have to say, I also thought about it, but somehow it's difficult to see where to start in some ways. Are you aware of any significant uptake of things like Apex OS, AutoWare in the agricultural domain?
To be honest, I'm not. I think it appears a little bit in some of the larger areas, larger agricultural OEMs, so John Deere. I'm pretty sure they use it. But when you come down to smaller robotics companies, I haven't been able to delve deep enough into everyone's technical solutions to work out quite how they're going about it. I think people have investigated a few of these options. I'm not using them for one reason or another, but I think from what I'm seeing in the way the automotive industry is now engaging, whatever blocks were there before in terms of the scales they're looking at are starting to go away. We're being approached very regularly now by automotive companies, especially integration companies who are very keen.
Yeah, no, it would be good if there were a few pointers on how to begin in some ways, because it seems to be almost a jungle, and it's difficult with all the different words that you say here, right? Just on this slide that you still got, where is the path through this jungle for the agricultural research community, for instance, to go into that area? Because I think there is a wealth of readily available technologies there.
No, that's a fair point, and no, we are here to help trying to do that. So the talk in, what's the date? I think that's the 14th of next month, possibly. I have to check. I have to check our website. That's with 2 different automotive companies and a company from the US who will have solutions for robotics. So there's a company who have an embedded computer. So I think it's based on a Renaissance platform, like the one that's a TI one. Renaissance platform. There's a company that produces a sensor fusion system. And there's another company actually from the nuclear industry who produces a sort of a middleware, agnostic middleware. It's quite hard to describe, but it's a platform of its own. So there were options there, and there are ways we're starting to try to link. But yeah, you're right, more work needs to be done, and I'll try to find a better way of bringing these all together.
Great. Thanks, Eliot. We can follow up at some other point. Cheers.
Mia, please, go ahead.
Yes, thank you for the interesting talk. So there are lots of overlap between what you are doing in your kind of activities, and also a lot of agriculture, food related research in the university area. But at the same time, there's a bit of distance at the same time. Do you have any kind of views or suggestions about a kind of research that you are difficult to do in your institution, and you know, kind of research topics that academics, university researchers should actively look into, you know, and contributing to your business to be easier? Do you have any suggestions?
I think that's kind of I might have to flip that question around, unfortunately, back at the community here. Agri-EPI Centre is very much here to help the Agritech community and help them in facilitating what they need to do. We're not in the position to try and force people down a particular route. We can only see what the community needs and try to give the capabilities that it needs. So there's a poll that's come up as a bit of a discussion piece to try and understand what people really need. I think the main one is question 3, asking about what people need to, what people really need from, I guess, government and from wider infrastructure to be able to really push forward their research quite hard. Us as a company, we can see needs. So like I've said, we can see a need for collaboration, and we can try and pull money in from government to try and facilitate that need. It's very much in the
Eliot, I fear we lost you again. Hello.
industry-led.
Hello,
Well,
Eliot. Are you with us?
Yeah, I'm back with you.
Okay. Now I hear you, but I think we lost you in the last 20 seconds. So if you can, I'm sorry, repeat your conclusion, or at least trying to help us.
Mostly, I think we're not answering the question directly. Yeah, we're here to facilitate you, and so if you have needs, come to us, and we will eventually try and find a way to fulfill those needs.
Okay, so there is also a question in the chat. Lillian was asking, this is related to the beginning of your talk, about your activity in Kenya, and then she wanted to know a bit more about that.
Yeah, so to be honest, that's not my project. So I can put you in touch with people directly involved in that project. From what I know about it, it's trying to bring general precision agriculture methods to Kenya. So starting to use, say, satellite mapping to understand their fluctuations across the field, their variability, for example.
Okay. Now I have another curiosity, because from a technological point of view, I think, and this is also connected to what Mark and Fumiya were asking, from a technological point of view, automotive definitely we need part of the technology, but from an algorithmic perspective, it seems that the objectives are fairly different, in the sense that driving a car on a road and having an intelligent behavior on a road seems a very different environment and a very different objective than having an intelligent behavior on the field. So while we can use the sensors in a certain sense, we need a huge amount of work because of the differences in the environment and objective. What is your view on that, and what do you think are the closest point of contact?
Yeah, I agree. So there's a slide I skipped there, which was talking about this briefly. I think that the initial layers, so sensing, perception, perhaps some mapping layers, are very common indeed to the use cases. You're very right. The behavioral layers and the control layers are going to be somewhat different. So this is all about optimizing research on areas where we are very different, but trying to collaborate on areas where we do meet quite closely. And like I said, sensors perception, that's very key to that.
And what do you think is the sensitivity point? So what is the most crucial thing, if you like, the thing that we should really solve as a starting point, the most pressing thing?
In terms of collaboration, or in terms of?
In terms of bringing automotive technology into the agricultural fields.
I think it's having a common platform to do that on. You can't very easily bring in an automotive piece of software because it's written in a completely different platform to what we're using here, mostly. So this is about finding a common platform in the automotive space. That may be AutoStar Adaptive, that may be Apex, that may be a different platform entirely, but probably like to be AutoStar Adaptive, let's be fair. So if people do want to bring that in, you have to find a way to combine those two systems, and that does exist out there. You can find people to help you with that.
Mark, please.
Yeah, just as a follow-up, because I think the question about the differences between the automotive industry and the agriculture industry is quite interesting. And I think the main difference, as I see it, is while in the automotive industry, you're trying to minimize any interaction and impact on your environment, right? You're not trying to bump into things. It's all about avoiding, basically. While in agriculture, we really, really try to interact and somehow have an impact on the environment, be it tillage, be it seeding, be it picking, or whatever it may be. So I think that's one of the main differences. You need to get close. While the main domain in automotive is to stay away, in agriculture, it's often to get close in a very precise way. And that's probably also where the components that we need to develop become more interesting. So we can probably borrow a lot from the automotive industry when it just comes to get from A to B on a farm. But when it comes to actually interact with crops, etc., that's probably where the big challenges lie.
Yeah, a lot of it's about both require very good understanding of the environment, would you say? You're right, the behavioral layer, very different indeed. What we're trying to achieve ultimately is completely different. It's the opposite in many ways. But I'd say that the core processing could be the same. I've seen people use some of those core processing technologies in their systems. That's not unusual, which is good. And the same goes for sensing and perception. directly applicable in many ways, I would say.
Okay, I think, Mark, do you have any follow-up? Otherwise, our time is almost up.
No, I think I questioned out.
Very good. So
thanks a lot, Eliot.
Thank you very much, Eliot. Thank you very much, everybody, to attend this talk. That was a great experience. And of course, keep following us. There will be more in the future, of course. Thank you very much. For today is all. And see you soon at the next event. Bye-bye. Thank you.